Notating your diagrams. UML is a handy little symbol called note. I think I saw that one on. Yeah. Tagging your symbols. Sometimes you want to add some extra information, such as a class diagram, directly to a symbol. Although you could put a note symbol on the page, another possibility is to put the information right into the symbol itself through a tag, sometimes called a tagged property. A tag gets a name and a value. For example, you might want to put a date on a symbol, such as date equals January 1st, 2014. You can notate this through a tag. Figure 5-3 shows two tags added to a class symbol and a single tag added to a component symbol. So here is figure 5-3. This here is where it says two tags that were added. So a tag that gets a name. So the date equals this is set to there. And then that's the component tag that they were talking about also. So the date equals that, the owner equals that, the size equals that. So this is the class. So just again, to review, it says, sometimes you want to add some extra information so you can put the information to the symbol itself. So it's a tagged property. And it's a name and a value. So the date is set up to that. The owner is set up to that. So a single tag, there's a single tag added to the component. So this is what they're saying about the two tags that's added to the class and the single tag added to the component. Okay. So then says, okay. The tags shown in figure 5-3 are of the format name equals value, and they are surrounded by curly brackets. Remember to have tags show up in some case tools, you have to make them visible for the symbol. For example, some case tools have an option called Show Properties. Using this option allows the tags to show up in the symbol. Hi, Uga1, and hi, Titan Galaxy Clockman. I typically have more reading time, but we fell back here in California, and my body still thinks it is 8 something. So I am going to call it sleepy time soon. But I was trying to get a little reading in. Hi, Jay. Before I do that. Hi, Banger Squad. Okay, free to be UML. One of the great things about UML is that it gives you a great deal of freedom. For example, if you find a diagram that you don't care to use, you don't have to use it. You can still move through an entire software development process or methodology. For example, some people prefer to use sequence diagrams while staying away from collaboration diagrams. And some people don't use state diagrams and activity diagrams. Now, some purists might complain about this, but as a software engineer, you need to do what works best for you and your team. Further, UML is not intended to be used only for software engineering. Because UML designed it to be a general purpose language for modeling, and it can be used for all sorts of projects. For example, in one book, every chapter started out with the UML activity diagram showing the flow of sections in the book. Of course, most people will use UML for software engineering, primarily because many people outside the software field have simply never heard of UML. Another area where UML allows freedom is in methodology you choose. Although this book focuses on the Rational Unified Process (RUP) (RUP), UML contains a rich set of diagrams and symbols that work with nearly any methodology. Thanks to stereotypes, a method of creating a new symbol, you can even add symbols to UML. So if you're using a methodology with its own symbols, you are not trapped with those built into UML. Normally, you take an existing symbol and from it derive a new symbol that has similar but more specialized features. You put the name in the funny looking angle brackets, as in angle bracket, minus stereotype, angle bracket. However, there's an alternative. Rather than put the name inside the brackets called galamets, you can use your own custom icon. In figure 5-4, for example, we use the scroll symbol. Titan Galaxy Clockman? Nobody's seeing this? That happens. Hello, Richard Andrew Crosby. Hello again, Titan Galaxy Clockman. Elijah G. Gur? Is that for Germany? Or are you just feeling Gur? Or is that a comment? My hair is kind of Gur right now. Oh, anyway. Flipping. Okay. So this right here, oopsie, is what they're talking about. About how instead of just using this fancy here, they have this squirrel icon and they're able to put it in like that. So that compared to this. Elijah Q, I still don't know what Gur means, but anyway, flipping. In figure 5-4, this row symbol is a stereotype based on a class diagram. Because the stereotype creates a new type of symbol derived from another symbol, this is still a class, but a class used for certain purposes. In our case, we defined this as a class that's stored as a document. Okay. From now on, every time we create a new class, we use this symbol to indicate a type of class that can be stored. When we finally implement this class, we will probably derive it from a base class called something like storable. That means, then, that instead of creating a stereotype, we could recognize how this stereotype will be used when we ultimately code it in C++. And instead, just draw our diagram as a base class storable and derive a new class. The discombobulator, as shown in figure 5-5. Either is fine. Oh, if that message gets held into review, that's where it stays. I don't review. It just gets disappeared to the never. Okay, so for those who are interested and or missed out on the description, this is a whoopsie, other way. This is a C++ All-In-One ForDummies. That's what we're reading. Yep. Just an old school read it loud, but for a big book with big topics. All right, here we go. Figure 5-5. Here we go. Let me try that again. Okay, great. So there it says figure 5-5. You can get around using tier type classes by using abstract classes. Okay, so that's why we didn't. Because when I was taking advanced object-oriented programming, hi Josephine Claybo. I'm doing okay. How are you today? But yeah, I was using abstract classes to make everything happen, not a stereotyping. Hi Josephine. I see you. I'm saying hello. I gotta get back to reading. Okay, so this is the sortable, which the discombobulator comes from. Dr. Seuss book? That's not necessarily a bad thing. I like Dr. Seuss. Anyway, focusing. However, stereotypes. Actually, I graduated from UCSD. Like, they also like Dr. Seuss. There's a whole library there based off of him. So, if you meant that as an insult, it didn't quite land as one. Anyway, back to reading. However, stereotypes go beyond just classes. Remember that stereotypes in UML give you the opportunity to extend UML. That is, stereotypes let you add new symbols with their own new meanings. In the case of our scroll symbol, we extended the class symbol and still ultimately have a class. But we can stereotype other symbols, and that gives them a totally different or slightly related meaning from the original symbol. For example, we may have a special association in our application that specifically means that one class, the composite, holds instances of other class, the parts, in the form of a sorted list. We can do this in one of two ways: stereotype it or create a tag property. Figure 5-6 shows the relationship as a stereotype. Okay, here's figure 5-6. So it says you can use a stereotype to specify a type of association. So here's the discombobulator, and they're seeing how the discombobulator is a sorted stereotype of class 1. So this is shown as a stereotype relationship, and then we're going to look to the next page to look at how it can be set as a property tag. Tagged property. Okay, so here it says figure 5-7 in turn shows the relationship with a tagged property. Notice that with the tag property, the tag is in curly brackets. Tag is in curly brackets. So then figure 5-7, you can also use tag properties to specify the type of association. So this is the curly brackets. So class, curly brackets over to there, versus this is the curly brackets versus this having that special term that had effectively the two arrow looking things on each side. Okay. Not all keys tools support, not all keys tools support all the features of UML. However, UML 2.5 seeks to reduce complexity and also ensure that case tools provide a more consistent level of support. So going with a product that's compliant with UML 2.5 is the best bet if you want a consistent UML implementation. If you find that a feature is missing, you can typically work around it by using related features. Most UML tools, however, support both stereotypes and tag properties. Again, this is an older book, so you have to get the most recent version to see if that still holds, or just, it's even better just to Google UML and see what the current version is and what they have. There's usually a lot of how-tos. C++ and UML. When you study UML, you may come across various items that you know are present, but that you can't find in UML. Here we direct you towards some smaller parts of UML that have a direct connection to something in C++. Specifically, we talk about enumerated types, stack members, and templates. Oh, nice. Okay. Drawing enumerations. If you want to show an enumeration in UML, you can use a symbol similar to a class symbol, Remember that in C++, enumeration is a type, and UML symbols for types are called classifiers. Thus, in UML, you use a special classifier to show an enumeration. However, note that this classifier is really a class diagram that has been stereotyped. This is a good example of how you can use stereotypes. Figure 5-8 shows an example of an enumeration in UML. At the top is the stereotype name, enumeration. Under the name is the type, in this case color, and the compartment following are the enumerations themselves. So, in figure 5-8, UML includes a special classifier for enumerations. So this is the enumeration of color: red, green, yellow, blue, orange, violet. Then over here, enumeration color 2, and it's not very creative named, so they just same thing but 2. And this has the value set versus that which doesn't. In figure 5-8, we give 2 enumerations. The first one, called color, simply lists the symbols for the enumeration. The second one, called color 2, includes values for each enumeration. In C++, these 2 enumerations would look like this. So in this case, you have your color, your curly brace, you got your colors in there, you close your curly brace, you put your semicolon, and then you do your thing with the color 2, set all your variables that have the 2's in there equal to the values they're supposed to be, and then end with the curly brace and also the semicolon. Including stack members. Okay. In C++, you can include static members in a class. Static members are those members that are part of the class, but shared along all instances of the class. Normally, all instances of a class get their own member variables. Okay. But if a member variable is static, there's only one copy of the variable for all the instances to share. For this reason, people associate such variables as being part of the class itself, not part of the instances. In UML language, these variables have a class scope. Regular member variables have an instance scope. Member functions can also have a class scope. Such functions do not operate on an individual instance, and therefore can't access the member variables that are of the instance scope. Member functions can also have a class scope. Some functions do not operate on an individual instance, and therefore can't access the member variables that are of the instance scope. A common use of class-scoped members is to maintain a count of the number of instances. Here, you would have a class-scope member variable called, for example, instance count. This would be an integer. In the constructor, you would increment instance count, and in the destructor, you would decrement it. Because there's only one copy of the instance count member, each time you create an instance, you would increment the single copy. Thus, you would have a count of a number of instances. Okay, that's good to know. Figure 5-9 shows an example in UML, a class with 2 class scope members. The class scope members are underlined. In this case, the class is called Messed Up Website. We suppose that the idea is that every time you visit a poorly designed and unappealing website, you would create a new instance of this class and save its web address in the instance. This has 2 class scope members, a site count, which is a private integer, and a sets site count, which is a public function that returns the value of site count. We made site count a public function that returns the value of site count. We made site count private so that other objects can't change it. And although we didn't show it, you would increment and decrement site counts in the constructor and destructor respectively. Okay, so figure 5-9, you can show stack members in UML by using the class scope. So in this case, this is messed up website. Site count is int, and get site count also deals with int, and web address deals with string. So then this is what the pseudocode looks like. Well, technically this is a C++, what the C++ looks like. So you would have your class, then you have your private static, your public, you have your static of your get site count, then that has the string web address. These are methods or functions, whatever you call it. So that's the messed up, that's the constructor, and then the one that minus is the destructor. So again, the one that is the constructor gets the incrementing, the destructor gets the decrementing. So that gets the site count, it returns the site count. And then that looks, oh, I guess that's the destructor. Because all it does is set it to 0. Parameterizing classes with templates. Okay. So, UML includes a notation that you can use along C++ templates. We discussed templates in Book 4, Chapter 5. In UML terms, a template is a parameterized class. If you think about how a template works in C++, you can see that this makes sense because a template takes several parameters that are used by the compiler to build the class. Tip: when you add the template parameters, the UML standard states that if the parameter is of type class, you can leave the parameter type blank. That's what we need. That's what we did in figure 5-10. Note that the parameter called myType has no type after it, thus the type is class. Okay, so then that gets us to figure 10. Figure 10. To show templates in UML, use a parameterized class. So in this case, you have this templatable myType size int dual string is linked to there. This has a stereotype of bind string 2. In this case, that's a templatable of int 3. Figure 5-10 shows the UML parameterized class. It looks just like a regular old class symbol, except that it has a nifty little dashed rectangle in the upper right corner. This dashed rectangle contains the template parameters. Note in the figure 5-10 that we then declared 2 classes that use the template type. The first one is unnamed and simply specifies the parameters. The second is named dual string and shows an association back to the template class. A stereotype name bind appears next to the association arrow. After stereotype name comes the two parameters for the template. Here is C++ equivalent of this email diagram. Notice that the myType parameter is of type class. Okay. So this is what's going on for the UML. And then this is a C++ equivalent. You have your template. Hi, look at pop. How's it going? You have your template, class myType. You've got your int size, class templatable. Then inside that you have your public myType value size. Oh, that's awesome. Happy birthday. Are you enjoying it? Is it going well? Okay. I guess more reading. And here is some simple code that uses the template. In this code, we also use the two classes. Oh, it turned 12. That's a good age. In this code, we also use the two classes based on the template. Note that in order to get the name template instantiation, we use a type def. Okay, back to this part. So this is using the template. They say templatable. They set int 3. The ints. So in this case, template int size class templatable. So they set that to 3. They called it that. So then they said ints.value value 0 is set equal to 10. Then ints.value that position is equal to 20. Ints.value that position is equal to 30. C out its value 2, which will be at 30. In the line, type def templatable string 2, dual string is 2, institute value 0 equals abc, institute dot value 1 equals def, c out c dot value 1, and in line. So what's going to come out on that part is going to be the def. So the first thing that we're printing out is 30, and the second thing that I'll print out is def. And with the inline, that means there's going to be a line. Okay, and that is it for chapter 5. Chapter 6 is next, but not for me. Not tonight. Next for me tonight is hopping off the live stream. And again, we just fell back here in California, but I'm still feeling like it's 9 o'clock in the evening. Well, that means it's time for me to get some sleep. I got something to do tomorrow. I know that part. What exactly? I don't know. But something. Hopefully helping my boyfriend with something. That'll be good. Okay, that being said, I'm going to start heading out off the stream so I can do my nighttime thing and get some sleep. Alright. Looks like that's everybody. Okay. Well, thank you for everybody who came by to check things out. Sorry, it was a little on the dull side. Again, I don't really see how being a Dr. Seuss character is a bad thing. But, whatever. Go ahead and enjoy your day or night or whatever it is you happen to be experiencing. Just make the most of it. Thank you very much for those who took the time or will take the time to check this out. Bye-bye. Sorry, I'm going off stream now. Thank you for stopping by. Bye-bye.